Welcome to this week's CEEN 304 video. Today we will be breaking down the Bernoulli equation.
To start, you need to pick 2 points to apply the equation to. For each point, you will need to know the pressure, the specific weight of the fluid, the velocity, g, the gravitational acceleration, and z, the elevation at the point you chose, and the head loss at the end of the system. P divided by gamma is also known as the pressure head. V squared divided by 2g is also known as the velocity head. And z is also known as the elevation head. The sum of the pressure head and the elevation head is known as the piezometric head, which graphically represents the hydraulic grade line. The sum of the piezometric head and the velocity head is also known as the total head and graphically represents the energy grade line.
The Bernoulli equation is used to show how energy flows through a pipe. Some important concepts for the Bernoulli equation include the idea that it could be used in conjunction with the continuity equation, which is that Q is equal to V times A, or in this case, V is equal to Q over A. Also, in a pipe system, as the velocity increases, the pressure must decrease to keep everything constant. As water flows through the pipe, energy is lost. This is known as head loss. Head loss is a term that is used in the Bernoulli equation and is quantified as H lost. There can be major head loss and minor head losses.
So we use the Bernoulli equation to help us quantify the movement of water in a pressurized pipe system. It also shows us the energy grade line and hydraulic grade line of a system. If you look at the diagram provided from Professor Lee's lecture, we can see that the difference between the energy grade line and hydraulic grade line result in our velocity head. At the end of a pipe, when fluid is discharged into the air, pressure equals 0. At the surface of a reservoir, velocity and pressure equals 0. So the total head comes from elevation. When elevations of 2 points are the same, the elevation term would cancel out.
When setting up Bernoulli's equation, you must first select 2 points at the desired locations of the pipe flow. Typically, these points are the entrance and exit to a pipe, though not always. When writing your equation, neglect pressure and velocity at point A and neglect pressure at point B, due to the fact that the reservoir and the end of the pipe are in contact with the atmosphere. The reservoir is large enough to neglect the velocity as well. Thanks for watching. Be sure to leave a comment and let us know what you would like to have explained next. Like and subscribe.